Has anybody ever seen this before in their life? Just asking you guys, what does this mean here? Do you guys know what I'm talking about? What is this? What is this? This is A. In other words, you're in quadrant 1, and they call that A. Quadrant 2 is S. Quadrant 3 is what? T. And quadrant 4 is C. Does anybody know what that stands for? Yes. Yeah, actually, good job. It's the phrase, all students take what? Calculus. All students take what? Calculus. Now, quadrant 1 is A. Okay? So what I want to do here is I'm going to put A as positive here. Quadrant 2 is S. S is positive. Quadrant T is tangent's positive. Quadrant 4, cosine's positive. So what that's saying is, that's telling you that in every quadrant by the circular functions, quadrant 2, sine's positive. What does that mean about, here's quadrant 2. What does that mean about cosine and tangent? They're negative. Good. What about quadrant 3? Tangent is what? Positive. What does that mean about sine and cosine? They're what? Negative. Okay, you guys okay with that? Now what about quadrant 4? What does that mean? Cosine's positive. Sine and tangent are what? Negative. It's because of the circular functions. Because every point, ladies and gentlemen, in those quadrants by circular functions, right? Remember I gave you guys this last time? Your x coordinate's positive and your y coordinate's positive. So this is why in quadrant 1, all 3 trig functions, which is really all 6, are positive. Now, the reason I bring this up, if you say, okay, why are you talking about this? Well, if I said to you guys this, we're going to take a what? A ray. And we're going to rotate it to 120 degrees. If I said to you guys, can you tell me what cosine 120 is? Okay, cosine 120. What you're going to need to know, you can do this very simply. If you know about quadrant 1. All right? What do you say? Quadrant 1. Quadrant 1 is called your reference quadrant. Everything here is your point of reference. So if you know geometry, and you say, what do you mean I know geometry? Yeah, if you know geometry, ladies and gentlemen, you're going to be able to what? Answer this question, right? Yes, all the questions are specially chosen. They're not asking for cosine of 125 degrees. So it's not like you say, let me jump for my calculator. They don't want you to do that. What they want you to do, ladies and gentlemen, is know this. Say, what do we have to know? Know about your reference quadrant. You see, you have something special. I want to pick a color, I don't know, maybe green. And really, maybe we should transition to this line here. See that there? I'm going to try to move it. There we go. Here's what this is. Okay, you guys remember this here. This is going to be your point on your circle, right? If I said to you, you have 2 paths to the x-axis. Here's your x-axis. 2 paths. To get to the x-axis, what I can do from that point is I could use that path. Is that true? Or I can use this other path. This is what your book is saying. Okay? This angle over here, I'm going to use this notation. That path in green, would you guys say, is the shortest path to the x-axis? Is that shorter? In other words, is the green path shorter than the what? The brown path? The answer is yes. This is important details. This is known as your reference angle, theta. We need a reference angle, theta. So you say, what's this reference angle, theta? The reference angle, theta, and this is why I'm using the same color, is associated with the shortest path. If the angle in question is 120 degrees, this here is known as theta. What is your reference angle? Could you guys tell me what the reference angle in purple would be? What's that angle? It's 60. How do you know? Because this here is going to be 120. They're saying this angle here is 120. Okay? 120 degrees. So they're supplemental. Is that true? So what you're going to say here now is, yes, the reference angle will be 60 degrees. You go, how did you do that? Because 120, hold on. Yeah, 120 minus what? It's 180 minus the 120. So the straight angle, they're supplementary. 180 minus 120 gives you that 60-degree angle. This here, ladies and gentlemen, is your reference angle. So here's the deal, ladies and gentlemen. This is the process. If you know geometry, if you can tell me what cosine of that reference angle is, you can give the exact value. What's cosine 60 degrees? Do you guys know? What is it? 1 over 2. Is it square root of 3 over 2? Anybody know? Is it? How do you know? Well, you said, Mr. Judge, am I allowed to forget everything? I'll tell you no. In other words, go back to this. Go back to geometry. The S portion. You said, what do we do here? Do you guys remember this? This is what? 2, 1, square root of 3. So, ladies and gentlemen, guess what? What's that going to be? What's that? What's cosine of 60? What's the definition? Isn't the definition of cosine 60 what? Opposite over hypotenuse? So the answer is yes. So geometry is quadrant 1, ladies and gentlemen. Trig is quadrant what? 2. What does it mean for all students? What angle is the 120-degree angle in? What quadrant is that in? See this here? The 120 degrees is in what quadrant? Good. What do you guys know about quadrant 2? All students take calculus. In quadrant 2, ladies and gentlemen, sine is positive in quadrant 2. So if the angle is in quadrant 2 here, okay, this is what I'm saying to you. Theta is in quadrant what? 2. What that means is cosine of 120 degrees is going to be negative square root of 3 over 2. Not positive, but what? But negative. you see, you're going to use that system of all students take calculus. Because in quadrant 2, you can't see the S anymore, but that just means your sign is positive in quadrant 2. Tangent is what? Negative. Cosine's negative. So the reason we say quadrant 1 is a reference quadrant is if you know geometry, then that means you can now do trig. Okay, you guys okay with that? This is what we're transitioning to. So I want to give you guys a note here. What is sine now of 120 degrees? What quadrant is 120 in? This angle is in quadrant what? It's a quadrant 2 angle. Is that true? So what do you guys know about sine in quadrant 2? Sine is what? Positive. Okay. So what do you really have to answer? What's sine of the reference angle? The reference angle is still 60 degrees. Is that right? So what sine is 60? Oh, wait a minute. Something... Cosine is not square root of 3 over 2. What's cosine? Cosine is 1/2, ladies and gentlemen. That means this is negative what? 1/2. Okay? So this sine of 60, though, is going to be what? Square root of 3 over what? 2. What's your answer for sine of 120 then? Is it negative or positive? Positive. Positive square root of 3 over 2. And then this is all done without your what? Calculator. Right? So why is that? Go back over here. I'm going to have to erase it. Go back to this information because sometimes people say, I don't understand. Well, why is 120 degrees, that's over here, quadrant 2 angle, why is only sine positive? Because any point in quadrant 2, remember that? X is what? Negative, y is positive. Is that true? What do the circular functions say? Cosine of the angle is x, that means cosine's negative. Sine of the angle is y, that means sine is what? Positive. So they're just kind of telling you here, listen, quadrant 2 only sine's positive, and actually it's reciprocal cosecant. But the other two are negative. That's it.
So also the reciprocal is also positive again.
Mm-hmm. But they start with the 3 trig functions. So all you got to do is remember the acronym. What's the acronym? All students. Why is tangent positive? Well, because any point in quadrant 3, x is negative, y is negative. So what is tangent again of an angle in quadrant 3? Isn't that y over x? Well, if they're both negative, negative over a negative is a what? Positive, and that's for tangent. So, ladies and gentlemen, quadrant 3, this is what you're looking at. Tangent's positive. So they can ask you the same question. Let's see if you can put this together. A note, what is tangent of 120 degrees? Well, you need to know the reference. What's the reference? What's tangent of 60 degrees? Go back to geometry. What's the definition of tangent? Opposite over hypotenuse. Isn't that going to be just the square root of 3? So for the reference angle, quadrant 1, what's the story now? 120 is in quadrant 2. What do you guys know? Isn't that going to be what? Positive or negative for 120? This means only sine's positive for any angle in quadrant 2. What does it mean about tangent then? Well, 120 is in quadrant 2. So any angle in quadrant 2 for tangent will be what? Negative. So this is the trig part, ladies and gentlemen. The trig part means go to quadrant 2, 3, and 4. Geometry is quadrant 1. I call that your reference what? Quadrant. This is your point of reference. What do you guys think? Is that okay? Is that okay? What do you guys think? Let's ask you guys this question here. What if they gave you this? They want to know sine of 135 degrees, cosine of 135 degrees, tangent of 135 degrees. What are these values? Okay, they're talking exact values now. So I would say this here, we got to go through all that stuff. Okay, where is this? Come on, let's get you bigger. Okay. Where does 135 degrees live? What quadrant is 135 in? 2? Okay. So you start your ray in standard position. You rotate it how? 135 degrees. There you are. So they're saying that this angle here, that's your theta. That is 135 degrees. So where is theta in which quadrant? 2. Is that true? Well, what do we know for quadrant 2? Sine is positive. Cosine is what? Negative. Tangent is what? Negative. True? Okay. What's your reference angle then? In other words, this angle here is the reference angle. So for quadrant 2, how do you get that reference angle? Do you guys know? For quadrant 2. This is quadrant 2 information. What is it? Yeah, let me give you guys a nice equation again so you guys know. That theta plus the reference angle is a straight line. Isn't that 180? This is for quadrant 2, ladies and gentlemen. How do you solve for the reference angle? Well, the reference angle is going to be 180 minus theta. So the reference angle is 180 minus 135, because that's your angle theta. What's your reference angle going to be then? 45 degrees. This is what you need to know. Okay, so my reference angle is 45 degrees. So this is the reference quadrant. This is what I just found to be 45 degrees. And that should make some sense because 135 plus 45 is 180. That's the straight line right in here. Okay, you guys okay with that? What do you think? Is that one okay? Now, you say, what are they telling me? Can you go back to that 45-degree angle? Remember, quadrant 1 is geometry. Quadrant 1 is saying this. This is your special triangle. What was that? 1, 1, square root of 2. Is that true? So go back to your reference quadrant, quadrant 1. Go back to geometry, and then now tell me, we got to find what? Sine, cosine, and tangent. Okay. Sine 45 degrees. What's that? Is that 1 over the square root of 2? Square root of 2 over 2. What's cosine, ladies and gentlemen? What's cosine? What's that going to be? 1 square root of 2. What's this? Square root of 2 over 2. What's tangent of 45 degrees? 1 over 1, which is what? 1. And there it is. Now, this is just from the first week we started class. That's week 1. Okay, you guys okay with that? Is that week 1? Now, how do you apply the trig portion? All students take what? Calculus. This angle's quadrant 2, which means sine is what? Positive. The others are negative. So sine is positive. All right. The others are what? Negative. Positive square root of 2 over 2. Negative square root of 2 over 2. Negative 1. There it is, ladies and gentlemen. You're done. All students take what? Calculus. So this is a shortcut for getting these exact values. Just means go back to what? Geometry. But you needed to get the reference angle. That's all. Easy peasy lemon squeezy? Yes.
If this one is going to be on the test, are we going to show the reference angle and we find it?
Well, you know what? I plan to do it on the test. I would like to, but I have a problem. If you're using your the last thing I want you guys to do is use your what? You have to use your calculator for some questions. So some of the questions you got to use your calculator. We've been doing that. The other questions are using your brain. So I go, oh my God. There's a way to do that. You go, okay, part 1 of the test is you do the exact without a calculator, and then part 2, you get to bring out your calculator. Don't know. I have to kick that around. So maybe by the end of the lecture, I'll figure it out. I actually multitask. I triple task while I do this. I don't know. I would love to. If I had that extra day, maybe I would been in a better place to make that decision. But we're going to use this in our future, So not sure yet. Let's see what we got, how we do this. I'm not sure. Not sure. I might even take some time to give you a quiz on it or something, but not on Monday. You see what I mean?
So this isn't on our test on Monday?
Not sure. We'll see. I'm kicking some things around in my brain right now. See how this goes. Not sure. In theory, you guys already know quadrant 1. You just have to remember all students take calculus. See what I mean? Remember one thing. Calculators are good to do some things, but you don't want to rely on them for everything. You got to use your brain, because when you do other questions in the future, you're using your brain, not the calculator. Let's try this out. You guys ready for another one? How about if we do a quadrant 3 angle? You go, Mr. Judge, quadrant 3? Yeah, let's do something like that. Let's take a look. You imagine if you just started your homework, if you haven't started your homework yet, or you're going to start this weekend, because you go, oh. Is anybody in that boat? You haven't started your homework yet? Just do it. Say, Mr. Judge, I like these other classes better, so that's why I do my homework there. Your class gets to the bottom of the list. So I haven't started yet. That happens. Do you guys know that? That happens sometimes. Sometimes people do that kind of stuff. Let's do a quadrant 3 angle. Okay, you guys ready? What angle is this? 210. You guys okay with that one? So what I want to remark is, this is how it looks. You say, oh, this angle is what? This is my theta, 210 degrees. So they're going to want to ask you, what is cosine of 210? Well, sine of 210. Let's do sine first because we want to be systemic, right? And then what's tangent 210, right? What do you know about quadrant 3? The angle is in quadrant 3, 210. So what do you guys know? Tangent is what? Positive. Is that true? Yes. Okay. So the others are negative. What does that mean? Negative, negative, and this is going to be what? Positive. Okay, you guys okay with that so far? So far, so good? But what do you need to know, though? We need the reference. Is that true? Now, how do we define the reference? Because it's going to be a little different here. See that terminal point? You got to get to what axis again? The x-axis. Is that right? How do you get to the x-axis? Two ways. We can go across that path, or we can go across this path. Oop, we want a highlighter. Which path is the shortest? Anybody know? What path is the shortest? Purple? Okay. You know what that means? That means this. That means your reference angle is right here. Okay? That's where the reference angle will be. Okay, you guys okay with that? How do we get that reference angle, though? Let me tell you what I think. There's a couple ways I think you can think about it. If I say I'm going to take the angle theta. Let's see if you guys can see this here, right? This is a quadrant 3 situation. So I'll do it down here. My angle theta if I take theta, you say, where is theta here? Here's my angle theta, okay? And then if I subtract, or I go back the reference angle, subtract the reference. Okay. What does that equal? Let's do that again. Here's theta. Go back that reference in purple. What does that equal? Here's that theta. Go back. What happens if I rotate in the opposite direction? It's a negative, right? So I'm at 210. Rotate back theta. What does that equal? What does it equal? I'm not going to tell you. How much? Nope. Nope. I'm not going to tell you. Here's the deal. We rotated already from the start. 120. I'm here. But I back up and I subtract that reference in purple. What does that angle measure? Thank you. Isn't that a straight line? Yes. So how do you get the reference then, ladies and gentlemen? So in quadrant 3, the formula is different. How do we get the reference? The reference angle by using algebra is theta minus what? 180. That's my point. This is what we're doing here. Now, what was theta in this question, in this example? You know what that means? My reference angle will be 210 degrees minus 180. And what does that equal? That's going to equal what? 30 degrees. So you're saying, hey, Mr. Judge, that the purple angle here is really 30 degrees. That should make sense. Why does it make sense? 180 plus 30 is what? 210. I'll say that again. 180 plus the 30 is equal to what? 210. 180 plus 30 is 210. The reference angle, ladies and gentlemen, 180 plus 30, that reference angle is 30 degrees. So all you need to do now is this. You have to answer sine of the reference angle 30, cosine of 30 degrees, tangent of 30. What am I drawing? Remember I said to you, all you got to do is know what? Two special triangles. Remember? All I said, you just got to know two special triangles. So how do we use all this? Do you guys remember? How do I use that? Where's the 30 degrees at in this picture? It's right over here. Is that right? In other words, let me get rid of this. This is my what? 30 degrees. Because the other side is 30 degrees there. So you need to know that second special triangle geometry. What is sine of 30? Oh, you got to know the definition. What is sine 30, ladies and gentlemen? I'm trying to remember. Sine was what? 1/2. Good. Cosine, adjacent. What's tangent? Opposite over what? Adjacent, which is what? Let's go to 3 over 3. So if you know that special triangle, what do you guys do now for the 210? What is sine going to be? What's sine, ladies and gentlemen? Good. What's cosine? What's tangent? There you go. Easy peasy lemon squeezy. What do you guys think? All students take what? Calculus. Do all students take calculus? I think so. What about quadrant what? 4. Oops. Let's add a picture. Focus now on quadrant what? 4. What do you guys know about angles in quadrant 4, by the way? Huh? If I said to you, quadrant 4 now, okay? Quadrant 4 measures what? Let's do a 330 degree. So if they said, what is sine 330? What is cosine of what? 330. What is tangent of what? 330. Okay, you guys ready? We need the reference angle. Is that right? To use the reference quadrant. So how would I get my reference angle here? Do you guys know? Again, take a look at this picture. The path from that terminal point down to what? The x-axis. You want to go to the x-axis. This is going to help you. Compare that with, along that circle, which one is the shortest path? Which path is shortest? Purple. Again, there's a reason I'm doing purple, right? Why do I do purple? Because remember, you just have to go back to quadrant 1. It's your reference quadrant. So here's what we have to find. What is this angle in here? That's your reference angle. How do I get that reference angle? Do you guys know? This is quadrant, again, 4 here. This angle is that 330 degrees, okay? That's your angle theta. So for in every one of these questions, you're asking for sine theta, cosine theta, tangent theta, okay? Easy peasy lemon squeezy. How do you think in quadrant 4 we get our reference? Here's your equation. Tell me if you guys agree. Theta, it's not theta, theta plus your reference angle better equal what? Thank you. Isn't that equal 360? Theta plus the reference is 360. How do you get the reference here? Anybody know a little bit of algebra? What's your reference? 360 degrees minus what? Theta. So, ladies and gentlemen, these equations are all associated with your what? Reference angle. So, if you said to me, does that mean, since my angle here was 330 degrees, right? Does that mean my reference angle will be what? 360 minus 330? The answer is yes. What's this going to be? 30 degrees. Okay? So your reference angle, ladies and gentlemen, is the quadrant 4 angle. So all that means is this. Go back here. All students take what? Calculus. So if you said, what does that mean? Do you guys know what this means? Which, in quadrant 4, what do you guys know about quadrant 4? Cosine is positive. Just put a plus here. Sine and tangent are what? Negative. Easy peasy lemon squeezy. Because that's what it means. All students take calculus. Now, go back again, and you said, okay, does that mean I have to find sine 30? Yes. I got to find what? Cosine 30. And I also have to find what? Tangent 30. Don't you already have it? Is that true? What's sine 30? 1/2. What's cosine 30? Square root of 3 over 2. What's tangent 30? Square root of 3 over 3. So, let's go back here. 1/2. Square root of 3 over 2. What's the other one? Oh, square root of 3 over 3. Those are your final answers. It's all based on your what? Reference. So I've decided, just to let you guys know, I have decided to not put these exact trig values on your what? Test. Because I want to do more work. You see what I'm saying? So it won't be on test 2. It'll be on the, I'll figure out, maybe give a quiz or something. I don't know. We'll see. Okay, you guys understand what I'm saying? Because it is important, because what's going to happen in your future is we're going to solve trig equations and do some other work with this. So you have to know how to do this. If you reach for your calculator to do everything, it's going to be a problem. It's not so hard to learn. What you have to remember simply is what? Quadrant 1. What's quadrant 1 called? It's your reference. Yeah. It's your point of reference. It's like your compass. It's like your guide. That's what it means. It's all based on that. And that is based on, ladies and gentlemen, geometry, which is based on only 2 special triangles. You see, this stuff is doable. People say, oh, you can't do it. Well, you can't do it if you never do your homework. I mean, it just can't. It doesn't work that way. If you said, Mr. Judge, I think I'm going to take the class 5 times because I don't ever plan on taking my homework, doing my homework. Because that's how I do things. I just watch, but I don't do my homework. Now, why do I say that? Because that's what I used to do. I used to think that, oh, yeah, I just have to. People that know this, they just know it because they see it, and you have to see it like 5 times and never bother doing homework or crying or, kicking or screaming. That's what I used to do. So in high school, I took algebra like 3 times. Oh, I think I could do it. You see what I mean? It's not efficient or effective. So, for example, give you guys another example, just to kick this up. They can say, what is sine of negative 240 degrees? You go, they can give me a negative angle too? Yes. What do you guys have to remember? Anybody know? What am I getting at? What do you have to remember here? Yeah, the even and odd functions. You guys remember why you studied even and odd? Why'd you study even and odd? Because even here, you take out the what? You see that negative sign? It's out. And then what do you have here? 240. Which quadrant is this in? You go, I got to do, all students take calculus? Yes. So, I share this with students here on this. Yeah, I do this one. Where's 240 degrees at? It's quadrant 3. Okay. Remember this over here is your reference angle. So in quadrant 3, how do you get that reference angle? What is it? Theta minus 180 for quadrant 3. So we say 240 minus 180. What does that give you? So your reference angle is 60 degrees. So bring out your special triangle, right? I guess this is sine. Is that right? Okay. So, I mean, it's right here. So I just have to know what sine of 60 degree is. Copy. Sine. What's the definition of sine of 60? Opposite over what? Hypotenuse. Is that right? Square root of 3 over 2. Is that sine 60? What else do I do? Then that means sine of 240. What's sine 240 then? See if you're awake. What's sine of 240? It's negative. How do we know? How do we know it's negative? Because only tangent is positive in quadrant 3. So that means sine is what? So that sine will be negative. It's negative. Okay. Now, let me do this so you guys know. Let's do this here. You guys okay with that? What does that mean? How do I put this together? That means this becomes what? So this is a negative times a negative. What's a negative times a negative? Final answer will be what? So even those functions being even and odd will show up. So that's why you have to learn the even and odd. That's why you have to learn the geometry, those two special triangles that we did. It's because you start to put this all together in that system of all students take calculus. And you're going to be, and trust me on this, you'll be using that in other courses. This is why they have you learn it. So it's not a waste of time and energy where you say, boy, do I really have to spend this time? Oh, no, it's not wasted time. You'll see that in other courses. Okay, you guys okay with that one? Yeah, I have some ideas. I'm going to kick around. So I'm not going to put this. Let me double check that homework here for you guys here. I got to work with I don't know how many things I'm working with here. Let's see. How many of you guys found that interesting today? Anybody find it interesting? You go, wow. Anybody finding that interesting? Nobody finds it interesting? Wow. I don't know if I told you guys, when I went to that stuff I did this weekend, we met these fellows. There's these students who essentially they applied for a paid fellowship to work with state senators and, assembly people. So these nice kids. And for these nice kids that were there, so you guys know, they asked them, hey, how do you be a fellow? Should we major in political science? What do you think we do to get that kind of opportunity? And you know what they said? They said actually what? Said, no, not really. Said because they want a diverse group of people to be fellows, to bring different ideas and different perspectives. They said, you know what we really like is people who major in STEM careers. That's what they said. Isn't that ironic? I mean, I'm going to say this to you guys. Look, STEM careers are the highest paid careers and they're in demand. If you ever look at statistics about who gets paid the most, it's going to be what? STEM careers. So what I'm saying to you is the stuff we do here is stuff you do. It's an investment in your future and in your life. That's why you make it a priority. That's why you do that. And it's doable. If you said, what do you mean? Yeah, you got to go back to those two special triangles. There's only two. You got to know your definitions of sine, cosine, and tangent. You got to know about the reciprocal identities. Flip it over. Even in odd functions. And then you're starting to do something significant, but it's done in steps. But it'll be impossible to do if you never do homework. I mean, gee, really? I mean, that's something I learned. So everything I gave you guys today is doable. But I'm not going to give you homework on it for your test. And I'm not going to test you on Monday with this. Okay? I got some other ideas to do. But it is important. And, you know, like I said, it's doable. I don't think it's impossible. I think it's doable. But, you know, it depends on people and how they look at it and when they get to it and their approach. That's all. I mean, it doesn't matter where you start. What matters is where you end. So, you know, there's going to be opportunities for you, believe me, if you do STEM work. But, all right, I'll put up your study guide. I thought I actually put it up last night. I'm losing my mind here. I got to double check. I thought I already put it up because I'll say, here it is, take a look. Because I love doing that. It's already done, your study guide. So when I get home today, after all my sickening meetings, people think, oh, what do you do, Mr. Judge? Nothing? No, I work at night and in morning, all day, all night. So I thought I put it up. Maybe I left it out. But Canvas is a little weird yesterday and last night. I was like, is this my computer or is it Canvas? Because it took a long time to upload. And like, is that my computer? I hope not. That's all I need is another computer to go down. All right, what do you guys think? All right, I guess we'll see you guys later. Take care, stay safe, have a wonderful day. Let's see what's going on here. So there is supposed to be let's try that out. And here there's supposed to be another. So let's see. How's that? Audio is here. Let's get the audio. Although I can't, okay, I hear it. There we go. I hear it. It's there. So we do have audio, ladies and gentlemen. And let's see how this goes here. So nice. Where are those people? They have a test and then they disappear. Is that what it is?
I know.
Oh.
Honestly, that was because you sent an announcement that you weren't going to be here and I missed it.
That I wasn't? I sent an announcement I wasn't going to be here?
Oh, I thought so because I was like,
No.
why isn't there anybody here?
No, okay. So remember, we have, what's our acronym here? All students take what? Calculus. So we're looking at exact values here. So, okay. We must have knocked people out on that test. Good. Knocked them out. All right, let's find out here. We're going to look at some exact values today, ladies and gentlemen. Let's see where this is. Let's get to, I'm looking for our textbook. You guys can't see that, what I'm doing. Ah, where are you? All right, so I'm going to get out a few of these here for you guys to work on. Okay, so I'm going to have you guys warm up here with this. And I'm going to say, determine the exact values. Question 1. How about tangent 120? Question 2. Secant 240. Question 3. Cosecant, how about 5 pi over 4? Question 4. Cosine negative 5 pi over 6. Number 5, we're going to say sine negative 5 pi over 3. And one more 6 will say tangent of, this should be over 3. This 11 pi over 6. So I'm going to move all of these up here. Do a little bit of warm up. We're going to get nice and warm here. And remember, you're using the acronym of all students take calculus. Okay? All students take calculus. Good job. So here's what we're going to do. We'll get out the clock here. Try to find that clock. And let me raise this audio a little bit so you guys can hear. And let's warm up and wake up and see how this goes, okay? We're muted. Okay, good morning to all of you guys at home and here. We're trying to determine the exact values. Okay, we did talk about this before. This is all without a calculator, right? Because it is important for you to know and understand where these values come from. And all you got to do is know 2 special triangles. Geometry, essentially, right? So if they're asking for tangent of 120, remember what we said last time. Quadrant 1, all of these angles, and if you said, what angles are we talking about in quadrant 1? Well, these are all angles that are less than between 0 and 90 degrees. Is that true? What did I say this was known as last time? Do you guys know? What do we call this? This was your reference quadrant. This is where geometry lives. This is my point, only 2 special triangles you got to know. So if they're going to say to you, hey, what is tangent of 120? What do you guys notice right off the bat? Right off the bat, when you start at 0 and you rotate to 120, where is this angle? That's in quadrant what? 2. So this is 120 degrees, quadrant 2 angle. You need to know the reference angle. And you say, well, what's that reference angle? Well, we talked about this. This is really where the reference angle is. You need that point of reference. If you don't have that point of reference, you're not going to answer the question. Because really, number one, you really want tangent of the reference angle. But how do you get the reference angle for quadrant 2? What's the reference angle? Do you guys know what the reference angle is? It's 180 minus 120, which is going to be what? This is 60 degrees. 180 minus 120. So remember, in quadrant 2, right, you get this reference angle, quadrant 2. The reference angle is 180 minus the angle in question, which is 120. So you're going to have to put here, right, that 120 here. This is the angle that they gave you. And yes, that's going to give you a nice, 60 degrees. So this portion here is 120. Your reference angle is 60 degrees. All right, and so you say, do I have to know what tangent of 60 is? You do. And now, here's what you get out. 60, 60, and 60. So remember, you have to get out your special triangle. So that tangent of 60 degrees, what's the definition? Do you guys remember? Because now you get to use this special triangle. Tangent of 60. This is your reference again. This is geometry here. So tangent of 60 is going to be what? Anybody know? What's tangent 60? Is that just the square root of 3 over 1, which is what? Square root of 3. Now, that's not the answer to the question, but that is maybe the answer. You say, what do you mean? Because remember this, we're trying to answer tangent of what? 120. This is going to give us our answer. You say, what do you mean? Well, what do you guys know about an angle in quadrant 2? Theta is 120. This is the angle they're asking. So that angle lives in quadrant 2 where sine is positive. What does it mean about tangent then? What does all students take calculus mean? Only sine's positive, which means tangent is what? Negative. So the final answer is negative square root of 3 here. So ladies and gentlemen, there it is. And that's the work you have to go through. You have to go through that reference angle. You got to go through the path through trig is geometry and algebra. But there you go. I wish I had my applause button. Right? I'm going to figure out how to get those. Maybe that's part of my spring break chores. How do I get my sound back? You guys know? All right. Question number 2. Secant 240. So number 2, secant 240 degrees. Remember, what do you really have to answer? We got to know what cosine 240 is. Is that right? We just take the reciprocal. So cosine 240, but remember, this is a trig question now. We're in trigonometry. We got to find out, let's get rid of all of this other stuff, right? Let's get rid of the prior, question. Now, 240 degrees. Let's get that ray in standard position, and we rotate this 240, And you say, oh, look at that, Mr. Judge. That angle is in quadrant what? 3. That's a quadrant 3 angle. So I need to know my reference angle. Right? This is where the reference angle lives. It's the shortest distance from the what? From that terminal point to the positive x-axis. So there's my reference angle. But it's quadrant 3. How do you get a quadrant 3 reference angle? Right? Do you guys remember? What does a reference angle equal in quadrant 3? Huh? It's a different formula for quadrant 3. How do you get it? Yeah, I think I'm going to say to you guys, theta, which is 240. Right? Theta is equal to what? 180 plus the reference angle. Is that true? So you go 180 plus that reference angle is theta. So how do I get the reference angle? Isn't it theta minus 180 now, if I do some algebra? So the reference angle is theta. Okay. So I'm going to say if your angle, I'm going to put it in blue because we're talking about theta. Theta, oops, is in quadrant 3. So what that means is your reference angle is going to be, what is that? Theta minus 180 now. And so the reference angle is going to be, since theta is 240, 240 minus 180, what does that give you? Isn't that what? Is that 60 degrees again? Oh my God, 60 degrees, okay. Well, I'm sorry. Well, I think I have that information. So all I need to know now, since my reference angle is 60, what's cosine of 60 degrees? I think I have that special triangle still up there. Look at that. What's cosine 60? What's the definition? Anybody know the definition of cosine of 60? Isn't it adjacent over hypotenuse? So what's it going to be? 1/2? Okay. So you might say, okay, Mr. Judge, I understand that, but what happens next? Right? We got to remember all students take what? Calculus. What does that T stand for in quadrant 3? Tangent is positive, which means cosine is what? So ladies and gentlemen, it's just going to be negative now. So this will be negative what? 1/2. So this is how you do it, ladies and gentlemen. This is how you do it. All we used was all students take calculus because you're really talking about circular functions and what, quadrant that terminal point lives, x, y coordinates live on that Cartesian coordinate system, the plane. But we're not done because they asked us for what? Bless you. They asked us for secant. So what's the reciprocal of negative 1/2? Huh? Negative 2. So ladies and gentlemen, here's a real answer. It's negative 2. Easy peasy lemon squeezy. Okay, now what about number 3 now? And you go, okay, what do they do with number 3 here? They gave you what? This is cosecant of 5 pi over 4 here. So they gave us a radian measure for our angle theta. Radian measure. So cosecant, we have to remember here, is really the what? What's cosecant? It's reciprocal of sine. Now, I'm going to give you guys a little secret here. You're going to have to tell me what quadrant this lives in. And here's the key here. You guys see this here? You see pi over 4? What angle is pi over 4? That's 45 degrees. Is that true? So 5 pi over 4 is like 5 times 45 degrees. Is that true? You guys okay with that idea? So go to that. It's multiples of 45 degrees. So if I said to you guys, well, let's figure out what quadrant that's in. Here's kind of what I do with this. "45 degrees, if I rotate my ray, here's 45 degrees. That's 1 times 45. This will be 2 times 45. This is 3 times 45. This is 4 times 45. And then this is what? 5 times 45. So it's really a 225 degree angle. So this angle lives in quadrant what? 3. Is that okay? Do you guys understand what's going on with that? Do the multiples of 45. You say 1 times 45, 2 times 45, 3 times 45. Oops, sorry. 1 times 45, 2, 3, 4, and then finally what? 5. Okay? So that's kind of how I see that. Or you can multiply 5 times 45, and that gives you your answer too. So that angle is 225. Is that right? And that's a quadrant 3 angle. So altogether, this is a 225 degree angle. So I need sine now. And you go, okay, well, what do we do with this? Well, I need sine of 45 degrees because this is my reference angle, right? So sine 45 degrees or pi over 4. Do you guys remember this is the second what? Or maybe this was our first special triangle, but it's really the second one that we encountered today. So we just have to go back to what? 1, 1, square root of 2. That reference angle, this is pi over 4. And then what's the definition of sine? Do you guys remember? It's 1 over square root of 2. It's opposite. Is it opposite over hypotenuse? So I'm not gonna what? I'm gonna say this to you guys now. I'm not going to rationalize the denominator here. Okay? This was pi over 4 here. 1 pi over 4. But I'm going to leave it this way. There's a reason why I leave it this way. Does anybody remember? I just have to figure out if this is positive or negative. So what do we know about this here? In quadrant 3, we have all students take calculus. That means tangent's positive. What does it mean about sine? Sine is what? It's negative. So this is a negative what? One over square root of 2. Why did I not rationalize the denominator? Because I need the reciprocal. Good. It's negative square root of 2. Because they really asked for cosecant. So, ladies and gentlemen, this is kind of, again, this is a real big deal. You do want to know where these things come from. It's fundamental. All you got to do is remember is all students take calculus, and just remember to rotate your ray across your circle here. So there are a lot of fundamental ideas here with this. Question number 4 is what? Is that cosine negative 5 pi over 6? So you get cosine of a negative 5 pi over 6. If you ever see that negative angle, what do you guys always do? Always. What would you do? Use your what? What do you guys want to use if it's a negative angle? Is cosine even or odd? It's even. So what does that mean? It means I don't care that you're negative. All right. You guys okay with that? It means you don't care it's negative. That's what it means. The next thing to do is focus on the pi over 6. What does pi over 6 represent? How many degrees is pi over 6? 30 degrees. So again, you got 5 times 30 degrees, which is going to be what? What's 5 times 30, by the way? Is that 150 degrees? So I'm going to go back number 4 and say, okay, I got to find 150. Rotate your ray to what? 150, and then the angle's in quadrant 2, so you have a quadrant 2 angle. And in quadrant 2, sine's positive, cosine and tangent are negative. But what's the reference angle going to be if this is 150? Do you guys know? This is the reference angle. I'll give you guys a big hint. You know what your reference angle is going to be? Right here, pi over 6. 30 degrees. So it's no coincidence. If I focus on that multiple of pi over 6, like I did prior, pi over 4, that's going to be your reference angle. Those are your reference angles. So those questions are a little easier to find. Okay, those are a lot easier, I would say. So if my reference angle, again, is pi over 3 or pi over 6, let's go back here. Okay, there's only 2 special triangles. This is what I say to students. There's only 2. You just have to remember some fundamentals of what? Geometry, right? Because if this is 30 degrees now, right? I have to know cosine of 30 degrees. So cosine pi over 6, which is 30. What's that going to be? What's that definition? What's cosine 30? Cosine 30 is going to be what? Isn't that adjacent over hypotenuse? Now, I think so. Is that right? All right. Now, what quadrant is that angle in? Quadrant 2. What do you guys know about cosine? Since all students take calculus, that means cosine's negative. Is that right? There you go. So it's going to be a negative angle. So your final answer is going to be this. It's going to be a negative what? Square root of 3 over 2. There you go. Final answer. So you just have to find the reference angle, geometry, in order to do trig. So the path to trig is what? Geometry. Sine negative 5 pi over 3. Okay. What do you do with that negative? What do you do with the negative? Is sine even or is sine odd? So we can pull out that negative sign. Is that true? All right, so notate that. The negative sign is outside now. So you want to notate that. So you're really going to focus on sine of pi over 3 here. And again, you go, oh, here's pi over 3. What's pi over 3 measure, by the way? Is that 60 degrees? Okay, so what's 5 times 60? The angle is 300. Is that true? Easy peasy lemon squeezy. 60 degrees. Ah. So what is sine of 60? I have my special triangle. Did we do that? Was this pi over? Oh, pi over 6, this is 30. Okay, good. What's sine of 60, ladies and gentlemen? You got to know what sine of 60 is, sine of the reference angle. What's your definition of sine again? Sine is what? Anybody know? I wish I had my sound effects. It's opposite over what? Hypotenuse. Okay. Now what do we do with this? What do we have to remember about the angle? Where is 300 degrees again? Quadrant what? Let's see. Start your ray on the positive x-axis. Rotates where? To 300. It's in quadrant what? What quadrant is that in? Is that quadrant 4? If it's in C, all students take calculus, that means cosine's positive, but it means sine is what? Negative? Okay. So you might say, what does that mean? What that means is sine of what? 5 pi over 3 is negative square root of 3 over 2. That's negative. So this one is negative. What's a net minus a minus now? Right. So final answer, ladies and gentlemen, here, don't forget, we had to find a negative sine of 5 pi over 3. So negative times a negative will be what? Positive. Here is your final what? Answer. So how does that feel? Is that okay? You guys start to see how you go through the process here? You're using everything we talked about? And then what about this one? Tangent of 11 pi over 6. You say, how do I handle tangent 11 pi over 6? Well, tangent of 11 pi over 6. That's number 6. Tangent. Okay? There's your reference angle. These are easier than the degrees. What does 11 pi over 6 measure again? I'm sorry, what does pi over 6 measure again? Is that 30 degrees? All right. And then you got this 30 degrees. What's 11 times 30, by the way? Anybody know what 11 times 30 is? It's 330. So this would be 330 degrees, right? So what quadrant is that in? 330. Quadrant 4. It's a quadrant 4 angle here. What happens in quadrant 4? Cosine's positive, so quadrant 4. All right. So we need to find tangent of 30. Go back to your special triangle, your 60, 60, 60. But remember, we're looking for that angle. We have to use the definition of tangent. What's tangent going to be? Opposite over what? Adjacent. What's that going to be then? 1 over the square root of 3, which will be what? Square root of 3 over 3 when rationalized. We rationalize that denominator. But we have to find tangent of 330. All students take calculus. What do you guys know about this? It's negative. Is that right? So it'd be negative what? Square root of 3 over 3. There you go, ladies and gentlemen. All right. What do you guys think about these that we just did? I'm going to give you guys a few more to try yourself. Now that you've seen a few of these here. Secant, ladies and gentlemen. 17 pi over 3. 8. Cotangent. Negative pi over 4. And 9. I'll say sine. 3 pi over 2. 10. Cosine. Negative 3 pi over 2. Now that you've seen a few of these here, we're going to give you guys some time to try these out here. Okay? So try them out. Let's see what you get. See here. All right, did we get the mute off? I think we did. Okay, so ladies and gentlemen, how do you should tell me how to do this. How'd you guys do this here? This is secant what? 17 pi over 3. What's so important about that multiple of pi over 3? Is that 60 degrees? Okay. So that's a 60-degree angle. Do you guys happen to know what 17 times 60 is? You know, I'm going to have to get out the TI. Let me see if I could do that here, okay? All right. Welcome back, TI. I was finally able to do this, ladies and gentlemen. All right. Isn't there a way to get rid of all that other stuff around it? I forgot. Anyway, I have to still play with that. Okay. So 17 times 60. And what does that give you? 1,020. Okay. So what I want to go back to the iPad and say is this. Didn't we talk about coterminal angles? What does that mean? What is this coterminal to, 1,020? Right? How would you start to find what it's coterminal to? I don't know what it's coterminal to. So I'm going to subtract. I'm going to go to my TI here, right? I'm going to subtract what? 360. Is that right? So I'm going to say, okay, 10, 20, minus 360, minus another 360. And what do we know? We're finally in the interval from 0 to 360. So 1,020 degrees is coterminal to what? 300 degrees. Okay, you guys okay with that? You guys see my point? We should have put that on your test. So this is the same as secant of what? 300. That's my point. Because they're coterminal. All right, here we go, ladies and gentlemen. Here we go. Now, how do we do the rest of this process? I think I have this here. So what is secant now of the reference angle 60, because we're going to have to deduce our answer here using this. I got to go and say, okay, what is secant of 60? Maybe you say, I don't like secant. I like what? Cosine. Okay, what's cosine? Isn't cosine a 1/2? Is that 1/2? So what is secant? Isn't that reciprocal? It's 2. Okay, is that true? Double check. Because I'm not even awake yet, and I haven't had my coffee yet. I'm still nursing my coffee. You guys have your coffee yet? No? Aren't I just using that same special triangle over and over and over again? Okay. So 300 degrees, what quadrant is that in? It's quadrant 4. What do we know about quadrant 4 angles? Only what? Cosine's positive. Is that true? All students take calculus, cosine, and actually secant. So for 300 degrees, oh, we have our answer. It's going to be what? There it is. It's the same. We don't change it. It's not opposite. It's what? 2. There you go, ladies and gentlemen. Easy peasy lemon squeezy. Is that right? So this is the logic you want to go through. And then cotangent, you might say, how do I handle cotangent? Well, what do you guys know about this? Probably is better for you to find what? Tangent of negative pi over 4. And what do I know about tangent? Isn't tangent odd? So I can pull out my negative sign. Is that right? Is that true? Now, what's tangent of 45 degrees? Isn't that 1 over the square root of 2? So there we go. Well, I'm going to leave it this way. Good, I'm going to leave it this way. Why am I not going to rationalize the denominator? Yeah, I need cotangent. So that's going to be negative what? Square root of 2. There you go. So that one's pretty simple. Because I need the reciprocal of that. And there it is, ladies and gentlemen. What do you guys think? Is that okay? And what did I do with you? What did I do for sine of, what is this? You might say, Mr. Judge, there is no reference angle that's 90 degrees, because isn't pi over 2 90 degrees? Then 3 times 90 is what? Isn't that 270 degrees? How would you answer this one? Remember this, okay? 270 is really technically not in any quadrant, right? Remember, you start here, and it's positive, and you rotate it 270. It's not even in a quadrant. You can't say it's in a particular quadrant. But what is sine? Is it the x value, or is it the y value, ladies and gentlemen? Do you guys remember? Sine is the y value, isn't it? So what's the y value here? 0. So there you go. It's going to be 0. So you're going back to what we already know. We already did that. It's going to be 0. Anyway, that's 0. So hopefully all of that now makes sense, because it's a circular function. It's the y-coordinate value. Cosine's the x-coordinate. Okay, you guys okay with that? Did I make a mistake? You never know. I might have made a mistake. Anybody know? Did I screw up on that? No? Okay. Now, what about this, ladies and gentlemen? What about cosine of negative 3 pi over 2? So what do we know? Oh, cosine is what? Isn't cosine even? Since cosine is even, what could we do with that 3 pi over 2? Yeah, see what I'm saying? It doesn't matter if it's a negative angle. Then that's the same as the positive angle. So it's actually, again, this is the x-coordinate. Is that right? That's the same angle, 270. Okay. What's the x-coordinate now? Yeah.
So like, is that 270? Is 0 negative 1? Because like,
Wait a minute, hold on. What's the coordinate? X is 0.
negative 1.
Y is negative 1. Oh, is that a typo? I think that's a typo. All right.
Did you make it or
Huh?
did you get this offline or like did you make it? I was
Oh,
wondering.
I found it online.
Oh,
0, negative 1. If there's an error, I found it online. I never made it. Good job. So, should we color coordinate this again? I think if you guys remember. Gotta find that typo. Gotta fix it. Yeah. I don't make mistakes. So I must have found it. 0, negative 1. All right, let's fix this answer here. So the y coordinate was negative 1 for the prior answer, right? So if we go, okay, what is this? Yeah, so this will be negative 1 because it's the y coordinate. Okay. And then this is going to be what? 0. Good. And I forgot, but I'm going to think about this. Come on. What is that? Oh. I don't know. We somehow have to establish connection. So I think X was colored orange. And this was colored what? Green. Anyway. All right. Now I'm going to give you guys a note here. Here's something I'm looking at your book, and I like this kind of question in your textbook. And where did it go? Where did it go? Let me get this here. Okay. So for this example, here's what we're going to say. Let theta be pi over 6. Oh, no, why then? It somehow loses my connection here. Come on. So theta is pi over 6. They're going to want to know, what is cosine? Actually, it has to be pi over 3 for some of these questions. So what is cosine here of 2 theta and cosine 1/2 theta? Okay, what are they really saying here for these two? They want you to do what? What is theta? This is pi over 3, right? So what's double pi over 3? That's cosine 2 times pi over 3. Is that right? And this will be cosine of what? 1/2 times pi over 3. So here they want you to answer what is cosine 2 pi over 3. And here they want you to answer what is cosine of pi over what? 6. Is that true? So how would I answer the first one? What's my reference angle? Go over here, ladies and gentlemen. It's a multiple of pi over 3. What does pi over 3 represent? This is a reference angle. Isn't that going to be what? Is that 60? So what's the angle? What's 2 times 60? Is that 120 degrees? All right. What quadrant is 120 in? Is that the second quadrant? What do you know about the second quadrant here? What is it? Sine is positive? Is that true? Okay, sine's positive. So in this example, it's going to be, since this is cosine, anyway. All right. You guys want to tell me what cosine 60 degrees is? What's that going to be? What's cosine 60? We have the triangle still there. It's the definition of cosine. Isn't that adjacent over hypotenuse? Okay. So then what's this going to be here now? This is going to be what? Cosine now of 120 is what? All students take calculus. What's this going to be? Is that negative 1/2? So, ladies and gentlemen, you're able to find that particular answer here. Good job. Okay, because this is really twice theta. However, what's cosine of, what is pi over 6? That's a quadrant 1 angle, is that right? So they're just saying, what is cosine now of 30 degrees? So where is 30 degrees again? You're going to look at the same triangle, but this time you got to look at what? The 30-degree angle. What's cosine? Anybody know? What's it? Square root of 3 over 2. Is that right? Okay. Nice. All right. That was pretty good. Now, what if they said was 2 cosine theta? And what is 1/2 cosine theta? Okay. What do we say theta was? What's theta again? What do they tell us about theta? Theta is going to be what? Pi over 3? So we have to know what 2 pi over 3 is. And we also have to know what 1/2 cosine of what pi over 3 is. Because they want us to let theta be what? Pi over 3. What is pi over 3? Is that 60? 60? I mean, that's not a reference angle. I mean, it is. It's a quadrant 1 angle. It's a geometry question, really. Okay. All right. So, what do we get here? This is 2 times cosine of 60. What's the definition? Isn't that 1/2? 2 times 1/2 is 1. Isn't this also 1/2? 1/2 times 1/2 is what? 1/4. And just for fun, does anybody happen to know what's the definition of cosine squared theta? Do you guys know what that is? That's thinking of cosine as a base, and you're raising it to the power 2. Okay. So if theta is what they tell us, theta is going to be pi over 3 here in this question here, right? They want us to find what is cosine squared of pi over 3. If you know what cosine of pi over 3 is, and you do, what's cosine pi over 3? It's right here, isn't it? It's 1/2. It's 1/2 right here. You just plug in the 1/2 there. So this is just, again, arithmetic. What is 1/2 to the second power? Isn't that 1/2 times 1/2? And what does that equal? Is that 1/4? So you're using, ladies and gentlemen, arithmetic to deduce all those answers. That's when they give you, an appropriate cosine. So I just want to say that you just can't, and generally speaking, these questions are very specially chosen. So don't try to think, oh, I'm going to plug in any angle I want and try to answer the question. If you do that, you're going to mess yourself up. Because these are all specially chosen. Is that right? Okay. Now, let me ask you guys this question here. I'm thinking of when you guys come back from vacation, spring break, maybe that first lecture day, giving you a quiz on exact values. Why do you think I would do that? Anybody have an idea? Why to do something crazy like that? Is that so crazy? Do you guys think, did anybody learn anything from the last test? What do you guys think about homework? Is homework the most important thing you could do? If you don't do homework, what's the story? You don't make progress. Homework, homework, homework. So if I have to throw that quiz in, and of course it shouldn't be worth a lot of points. It's not part of the grade. Maybe it's extra credit for a quiz because I didn't put it on the syllabus. So this is a legal document, right? I can't change your syllabus. There's no way I can change your syllabus. I can't change anything that's written in stone. It's a legal document. So what I can do is make it an extra credit quiz. It's not worth a lot of points. But I think the real moral of the story, though, is doing your homework is going to save your life. That's how it works. And if it means making it your priority, then you make it your priority. I think sometimes students like to put other classes first. They don't like making this math a priority. So people approach it backwards. They don't make this a priority. They make everything else. But yet everything else depends on the math. So if you make it a priority, it's going to make you a priority. So that's what I'm thinking of doing. Say, okay, when we come back, we'll have an exact value of, because you can't do a lot of other things without kind of knowing the fundamentals. It comes down to. So I think it's actually worth doing. That's my personal feeling. So I don't know. I'm thinking about it, but I already put in your what? I already put in, what did I put? In Canvas, your homework, starting with the exact values. So, ladies and gentlemen, there you are. I'm going to try to grade your test tonight if I can. I don't know if I can. We'll see. I'm going to try to do that. I got meetings tomorrow, all on Wednesday, that are crazy, crazy, crazy. But anyway, here's where we're at. Yes, question. Quick question. Scroll up. Right around here. Did you guys notice every one of these questions went down to those two special triangles and knowing the fundamental definitions in geometry? And then all you got to do is know where the angle lives. Quadrant 1, 2, 3, 4. All students take what? Calculus. Corresponds to these terminal points of x and y and the circular functions being positive or negative. That's it. All right, you guys, take care. We'll see you tomorrow. Have a great day. Wish I had my song going.